In this lesson, we're going to learn what I'm going to call sideways parabolas. We've talked about the fact that there are parabolas that can't go, or that go more than just up and down. There's also side-to-side parabolas, and we kind of got a taste for them in one of our first couple chapters when we were doing domain and range. But now you'll look at this first number 1, and hopefully you notice the difference here is the x and y seem like they're in the wrong spot. And you'll see this equation in the corner. It says x equals a times y minus k squared plus h. So again, it's a little bit off, right? The h and k seem in the wrong spot, the x and y seem flip-flopped. If you look at this slide, the up and down, this is what we've already learned. So now here's the parabolas that go left and right. You will notice that their equation, the x and y are flipped and the h and k are flipped, but the vertex is still hk. The axis of symmetry is different because think about a sideways parabola. I'm just going to draw you a little one right here. Axis of symmetry is the line that cuts that parabola in half. So for a sideways parabola, that would be a horizontal line. So you'll notice your equation is going to be y equals a number, and it's always going to be your k value. Same as a up and down. A tells us which direction our parabola opens. If A is positive, our parabola opens to the right. And if A is negative, our parabola opens to the left. So we're going to actually just graph a couple of these so you can kind of get the hang of that. Whoops. As I go here, we have h and k still, so I'm going to label those on my graph. Here's h, here's k. So my vertex, and I think it's important for you to actually write this out because it'll make a little more sense, is going to be 1 and then 2, opposite of what it says in the parentheses. My axis of symmetry, remember, is a horizontal line, so it's y equals 2. My a value is still in the same spot right here, so my a value is -1. Because my a value is -1, I know my parabola opens to the left. So I'm thinking it's going to look something like that. Okay, so I go to 1, 2, and I plot my point. Here's where it's really nice for us to know that how a parabola moves, and we have that pattern memorized. When a is 1, our parabola goes up 1, right 1, doesn't it? So you kind of have to turn your head sideways and make your parabola go up 1, right 1, and put a dot there, and then up 3, right 1. That's the easiest way, I think, to look at it, or even switch your paper and flip it, and then you'll be able to plot that point and you'll flip it back. So we wouldn't actually have those connecting there, right? So again, I'm going to go to 1, 2, and I go up 1, right 1, up 3, right 1. If you want to think left 1, up 1, left 3, up 1, that works too. And then I do the opposite reflection points, and I connect those dots. Tomorrow in class, I'm actually going to show you how we can rotate that using a paper, so hopefully that makes a little more sense to you. But that's all that there is to it. It's going to open to the left or the right. The one thing I will point out, though, is I'm not going to call this a quadratic function. Why is that? These aren't functions. They do not pass the vertical line test. So these are quadratic equations, we could call them. They're not functions. And actually, you'll see that if we solve for y, these are going to be square root equations, and we'd have them separate. Oh, there we go. I'm getting myself in trouble here. There we go. So let's try the last one that we're going to graph. We will hopefully see again that we have h and k. So my vertex is -2, -4. My axis of symmetry would be y equals -4. And my a value is 1/3. So I know my parabola moves to the right. Now this can be really hard because I don't know how to move with 1/3 probably. Maybe you picked up on the pattern, but I kind of doubt it. So when I go to plot this point, I know it's going to be -2, -4, but I'm not sure how to move from here. So to help me figure that out, I'm actually going to use my calculator. And I'm going to just plot the parabola y equals 1/3 x squared, because that's just going to be a normal parabola that goes up, but it's going to show me how I move with 1/3. So when I hit the graph, this is not the parabola we're doing for our homework, but this is the one that's going to tell me how it moves. So I'm going to look at this table. I know the vertex is at 0, 0. So when I go to 0, 0, well, that's not working too good for me, is it? Let's try that again. There we go, 0, 0. Notice the next point I can name is 3, 3. So on my graph, that's telling me that if I start at 0, 0, I go up 3, right 3 for that next point, or up 3, left 3. Then my next point here is 6, 12. 6 and then 12 would be off my screen. But if this is 3, 3 and I'm going to 6, 12, I would go up 9, right 3. So I know for 1/3 I go up 3, right 3, up 12, right 3. So that's the pattern I'm going to use on my actual graph now. So from here, up 3, right 3, and actually I don't think I'm going to fit a 12 here. So I'm just going to go ahead and connect these dots. You won't get a lot of them like that, but you have to be prepared to solve those.